Let us go for the next problem, which says combine n SHMs. So let us write down the component SHM. Let us choose this form. Now there are n SHMs, so let us attach index I, where I runs from 1 to n. So they all have frequency omega and they are collinear. So the resultant displacement will be x, and we get its form using principle of linear superposition. So it is summation over xi and in the previous video we did for 4 SHMs, and therefore we will just write the result. There I ran from 1 to 4, but here it will run from 1 to n. So the final or the resultant SHM will have the form where A is and this tan delta is given by next problem. Show that the particle under the influence of the following SHMs will be at rest, and x1 is given to be so this is the problem, and the answer is, let us first investigate the SHMs. Their frequency is same. They are collinear, and let us go to the phase diagram to get to the result quickly. SHM amplitude and phase. This is x1, a1. The phase is simply omega t. Here we have x2, amplitude is a2. Here we have omega t plus 2 pi by 3, so it is omega t plus 120 degrees. x3 a3, here we have omega t plus 4 pi by 3, so it is omega t plus 240 degrees. So let us make a plot. This is omega t line, and this is say a, because a1 is a, a2 is also a, a3 is also a. All are given to be of same amplitude. Now at 120 degrees comes another a, which is the second SHM, and at 240 degrees comes the third one. This is a. This is 240 degrees. Now let this be the x-axis, and this is the y-axis. This is negative x-axis, this is negative y-axis. Now this is 120, so clearly this is 60 degrees, and this is 240, and this is 180. So 240 minus 180 is 60, so this is 60 degrees. And now let us resolve x component of SHMs. Component along x-axis for the first SHM is a, because it is fully along x-axis. Now come to the second one. Its component will be along minus x. So it is a cos 60, but along minus x. So it is minus a cos of 60. And the same is true for this one also. The component of this a along negative x-axis is a cos 60. This is equal to a minus twice of a cos 60 is half, and therefore we have 0. What is the y component? So y component of SHMs, y component of the first one is 0, because it is along x-axis and y-axis is at 90 degrees and cos 90 is 0. So the first one has 0 contribution. Now the second one is this SHM along y-axis. This is 30 degrees, so it is a cos 30. The third SHM, that is this a, has a component along negative y-axis of amount a cos of 30 degrees. So it is minus a cos of 30 degrees, and therefore it is 0. So neither there is x component nor there is y component in the phase diagram, and therefore we conclude that particle is at rest. The three SHMs balance. Another problem: find resultant of three SHMs as given. So we come to the answer. Frequency is same. So let us directly go to the phase diagram to solve it quickly. SHM, amplitude and the phase. X1 has amplitude of amount 2 and the phase is simply omega t. X2 has amplitude 3 and the phase is omega t plus pi by 3, which is omega t plus 60 degrees. x3 has amplitude 5 and the phase is omega t plus 4 pi by 3, so it is omega t plus 240 degrees. So suppose this is omega t line, and let us put the first SHM of amplitude 2 here, and then at 60 degrees we have 3, and at 240 we have to put the third SHM, and 240 means it is opposite to this one of amplitude 5. Let us check whether we have done it correctly. This is 60, this is 120. Now if this is 60, this is also 60. So this is 60 degrees and this is 120. So 120 plus 60 is 180, plus 60 is 240. So we have correctly placed the third SHM, and these two SHMs being in the opposite direction will try to cancel each other out, but this one has larger amplitude, so the net contribution will be along this direction. It is 5 minus 3, that is 2. So we can redraw the diagram. So this is 2 and this is 2, which is actually 5 minus 3, and this angle is 120 degrees. Let us now complete the parallelogram. So the resultant is this one, the value of which we will find out. So A will be, say this is A, the resultant 2 square plus 2 square plus 2 into 2 cosine of the angle between these two SHMs, so which is 120 degrees. This is parallelogram law, and the answer turns out to be, this is minus half. So these two factors will cancel out and we have 2. So A is 2. So this length is 2. Now let us find out the phase. First let us find this angle. So let us drop a perpendicular from this point first. Now call this point B. Let this point be A. Let us call this D and let us call this C. And this A is actually 2, which we got. Now this angle, say, is alpha. So what is tan alpha? Tan alpha is AB by BC. Now AB is, this is 2, so this is also 2. So it is 2 sine of this angle. Now this is 120. So this angle is 60 degrees. Therefore, AB is twice of sine 60 degrees. And BC is CD minus BD. Now CD is 2 and BD is twice cos 60. So it is twice of root 3 by 2, 2 minus twice of half, and this is root 3. So tan alpha is root 3, so we get alpha to be 60 degrees, which is pi by 3. So what will be the phase of this resultant? So this was 2, this was 2, and this was the resultant, which was also A equal to 2. What is this angle? Now this was obtained to be 60 degrees. So this phase angle will be 360 degrees, which is the total one, minus 60 degrees. That is 2 pi minus pi by 3. And this is 300 degrees, or 5 pi by 3. So the answer is, for phase it is 5 pi by 3, and for amplitude it is 2. So this is 5 pi by 3, this angle.